All right, so we've gone through parts 1, 2, and 3. Part 1, you're drawing the triangle with the points A, B, and C. Part 2, you're using the midpoint formula, identifying the midpoints of A, B, B, C, and AC, and putting those onto your graph paper. Part 3, you're finding the slope of the line that connects A and B, and the equation of the line that connects AB, and the same thing for BC and AC. And you're going to use Green Glob's graphing equation grapher to graph those with the computer and make sure that the resulting triangle, that the vertices of that triangle are at A, B, and C, and you have the same triangle graphed by computer as you have drawn by hand. Um, and that's how you can check your midpoints. Be very careful on your midpoints because that's going to be needed in part 4. Using the previous two results, write the equation of the perpendicular bisector for each side of the triangle. That is to say, find the equation of the line through the midpoint. That's what makes it a bisector, is it splits a side in half, and these are chords, so it's a perpendicular bisector of a chord. And through the midpoint that is perpendicular to each side of the triangle. So why did I ask you to find the midpoint? And why did I ask you to find the equation? Well, you need the midpoint, 1.5 comma 8.5. Actually, let me go to the next page. Next page. We needed the midpoint, um, the midpoint of AB, which was 1.5 comma 8.5. And then the equation for AB was negative 1/7 x plus 63 over 7. We needed these two things so that now that we have these 2 points, A and B, here's the midpoint. This line here has a slope of negative 1 over 7, so this perpendicular bisector has to have a slope of the negative reciprocal of that. So what's the negative of a negative? A positive. So we're gonna flip it over. So instead of being 1 over 7, it's 7 over 1. Why? Because if you have two slopes, the slope of a line and the slope of a line perpendicular to it, when multiplied, always equal to negative 1, which means one is the negative reciprocal of the other. Okay, so all you have to do, if it was a 3/4, you flip it and it'd be a 4/3, but it'd be negative. And that thing would be the equation, or not the equation, the slope of the line perpendicular to 3/4 is negative 4/3. The only other thing you got to watch out for on these is, let's say you had a vertical line. If you have one of the equations is like x equals 5, well, that's a vertical line, and its slope is undefined. And because its slope is undefined, the slope that's perpendicular to it will be equal to 0. Okay, and its equation will say, instead of x equals 5, it'll say y equals whatever. So just watch out for that. If you have a vertical line, then you're looking, its perpendicular bisector has to be horizontal, which means its slope is 0. If you have a horizontal line, its slope is 0, its perpendicular bisector will be a vertical line. Okay, that's it. So now I'm going to do this. I want to write the equation in this step of this line here. Why? Because this line contains all the points that are equidistant from A and B. So how am I going to do that? Well, I have the slope now is 7, and I have y equals mx plus b, and a point that's on that line. The midpoint is not just on this line, but also on this one. So I'm going to put 8.5 here equals 1.5. Oh, that's not where the 1.5 goes. It's where the 7 goes. So I'm going to put in a 7 there because that's the slope of this line that I'm looking for, times 1.5 plus b. 7 times 1.5 is 10.5. And it's okay to use decimals here because I did it here. But if you wanted to be consistent and use fractions, you could change these back into 3 halves. And 8.5 is 17 halves. But as long as these aren't rounded, you see 1.5 is an exact value. It's exactly equivalent to the fraction. If it was like 1.666, no, use fractions in that case. Um, I don't want you rounding off anything because it'll throw off your results. So in this case, I'm getting away with it because 1.5 is exactly equal to 3 halves. But if it was like 2/3 or 5/3, 5/3 does not equal 1.6. It equals 1.6 with a bar. And therefore you can't represent that accurately in here, so use 5/3. Okay, but I'm getting away with it here. Um, So I'm going to minus 10 halves from each side. I'll get negative 2 is b. Therefore, y equals 7x minus 2. And that should be perpendicular to this line when I graph it. Let's check it. Boom. 7x minus 2. And does it go through the point 1/2, 1.5, comma, 8.5? It really does. It's hard to see here. Let me push that up. It's hard to see, but now look. You can see that point. It's 1.5, 8.5. There you go. So let's see what the next piece of the instructions are. So I got my line. Using the previous two results, write the equation of the perpendicular bisector. We did that on the next page. Graph these along with your answers from 3b with the green globs grapher to demonstrate that they do cut each side in half at a right angle. So you're going to have a picture that looks like this, and then you're going to have another one that has all the perpendicular bisectors in there cutting each side in half or whatever. Okay, you should do this before you proceed further. That is a really bad picture. I apologize. Let me draw it in two colors. I'm trying to make it a little neater. Um, so what I'm looking for is, let's say this is your triangle. When you found the equations and you found them properly, then here's some midpoints. All these lines you found should go through um, the sides of your triangles at right angles. Anyway, so there you go. Okay, so, and they should actually all meet in one point, but we'll get to that in a minute. So that's the check you want to perform, and that you would also want to copy paste into your results.